FST students, this is continuation of 4.3 and 4.4. We talked about reflections over the x and the y-axis, and we talked about translations where the graph is being shifted or moved. And now we're going to talk about the graphs when they are stretched or shrunk. And instead of, in this case, these will involve multiplication and division. So when the graph was just shifted left, right, up or down, you can remember that that was either addition or subtraction. Stretching it will involve multiplication or division. So if we have something like y equals 2 times f of x, we are multiplying on the outside, so this will stretch it vertically. Same thing as when we did translations. If we added or subtracted on the outside, it moved it up and down. This is going to double the y's, as f of x really is the same as y. So this is like y, we're doubling the y value. All right, so an example of this, if I start with f of x being this absolute value graph, starting at 2, 0, we're going up 1 over 1 on both sides. And I want you to graph y equals 2 times f of x. So this is going to double the y's, which is going to vertically stretch the graph. And it's important to note that a vertical stretch is the same as a horizontal shrink. So in this case, this point 2, 0, we're doubling the y. That's still going to be 2, 0. Still going to be this point right here. And then the point 1, 1, this point, would become 1, 2, doubling its y. The point 3, 1 is becoming 3, 2. The point 0, 2 is becoming 0, 4. And the point 4, 2 is becoming 4, 4. And then you can draw the graph and you can see that it would be vertically stretched. It's like pulling it up. This next example is 1/2 f of x. So we're going to take half of the y's, and this is going to be a vertical shrink, which would be the same as a horizontal stretch. So just like this, the point 2, 0 stays 2, 0. The original point 1, 1 would become 1, 1/2, which is right there. The point 0, 2 would become 0, 1, and symmetrical on the other side. And you can see we get kind of a fatter looking graph, a little wider graph that's been vertically shrunk, pulled down, or horizontally stretched, however you want to think about that. This last one, now we're going to take y equals -3 times f of x. So this 3, we're going to say, is going to vertically stretch things, triple the y's. This negative we learned in the last lesson is going to flip it. That is going to flip it over the x-axis. So again, the point 2, 0, that vertex point, would still be 2, 0, because we're like multiplying the y by a -3. The point 1, 1 would become 1, -3. And the point 3, 1 would become 3, -3. 0, 2 would become 0, -6. And you can see the graph has been vertically stretched and flipped or reflected over the x-axis. All right, now, if we work on the inside, so in this case we've got y equals f of 2x. So we're multiplying by 2 on the inside of the parentheses. That's going to make a horizontal change, just like your translations move things left and right. This is going to horizontally either stretch or shrink the graph. So since on the inside We think opposite of what you'd think. So that 2x on the inside will actually divide the x's by 2, which will horizontally shrink it, which is the same as a vertical stretch. So here f of x is the parabola with a vertex at 2, 2. We're going over 1 down, 1 over 1 down, 3. Y equals f of 2x. This is going to take half of the x's, going to horizontally shrink it. So our vertex point, this point 2, 2, would now become 1, 2. The point 1, 1 would become a half 1, which is about right there. 3, 1 would become 3 halves, or 1 1/2, 1. The point 0, negative 2 would stay 0, negative 2, because this half of 0 is 0. And the point 4, negative 2 would become 2, negative 2. So you can see everything has been horizontally shrunk because we're multiplying by 2 on the inside. This next one, f of x over 2. So now we're dividing by 2, so we're going to multiply our x's by 2. This is going to horizontally stretch the graph. So this vertex point 2, 2 is going to become 4, 2. Y is staying the same. The point 1, 1 would become 2, 1. The point 3, 1 would become 6, 1. The original point 0, negative 2 would still be 0, negative 2. And then the point 4, negative 2 would become 8, negative 2. Here's the new graph, which you can see has been horizontally stretched. Dividing meaning stretch, opposite because it's on the inside. This next one here, we've got f of x divided by 3, negative on the outside. So we know this is going to triple the x's. It's going to horizontally stretch it. And this negative is going to flip it over the x-axis. It's going to multiply the y's by negative 1. So looking at our original point of 2, 2, that point is going to become 6, negative 2. I tripled the x. I multiplied the y by a negative. The point 1, 1, the original point 1, 1, will now become 3, negative 1. And likewise on the other side, well, we actually have the point 3, 1. That's going to become the point 9, negative 1. The original point 0, negative 2 will become 0, positive 2. And then we'd have this symmetrical. And we get a graph that has been horizontally stretched and it's been flipped over the x-axis. We'll do some more examples in class, but hopefully that gets you an idea of how to stretch or to shrink a graph.